All right, I wanted to just help you guys get started with this practice sheet. We've done a few things now. Let's just stop, make sure that you can still do them. So linear programming, just gonna kind of help you get this parking lot problem set up. Looks like we've got a parking lot 600 square meters. That's like the size of it. A car requires 6 square meters, a bus requires 30. The attendant can only handle 60 vehicles total. Cars are 250, buses are 750. Basically, what do we want to do? You know, you might say, well, just bring all the buses in, but they might take up too much space. Just bring all the cars in. Well, you might not get enough money. So the idea here is to figure out like what's going to be the best combination of, well, of cars and buses. That's normally how these problems work, where you're trying to or you want to say that x and y are the unknowns in the problem. Now remember, the objective quantity, that's going to be the thing you're trying to optimize. It's almost always money. We can just call it profit. I'm going to let you fill that in. How much profit do you get for an x? How much profit do you get for a y? Let's talk about the constraints. Okay, this is one of those problems where we have two assumed constraints because nothing else is said. So we're going to say that we at least have to have positive cars and buses, no negatives. Now remember that first sentence we read? Actually, it's not the first sentence. Remember this sentence in the middle? It says that the attendant can handle 60 vehicles. Okay, really what that's saying is the total amount of x and y can't be more than 60. The total amount of x and y. Now there's a fourth constraint that has to do with the size of an x, the size of a y, and the total amount of space, the total amount of parking space that's available. I bet you can write that one. It uses the only numbers that are left. Now, when you graph these constraints, the first two constraints, x and y greater than 0, means that we're going to be in this positive region that's already shown here. The other constraint, x plus y less than 60, that's a good one to plug in zeros and get your x and y intercepts. So if you plug in a 0 for y, you get your x-intercept at 60. And if you plug in a 0 for x, you get your y-intercept at 60. I didn't want you to be fooled by that. That's exactly how this works. Let me recommend that you use a scale such that every one of these blocks is worth 5. So that means every other block is worth 10. I'm going to mark 10, 20, 30, 40, 50, 60. Maybe we'll just kind of save that one so we don't forget that that's 60. Might want to keep going here, 70, 80, 90, 100. Again, using a scale that every block is worth 5. That means every other block is worth 10. So 10, 20, 30, 40, 50. Again, here's my 60. I'll save that one. 70, and I guess we only get up to 80. So if I'm graphing this constraint, x plus y is less than or equal to 60, then I just needed both those intercepts that are at 60. 60, 0 to be exact, and 0 is 60 to be exact. Now you got one more to do, right? You got to figure out this constraint right here, and that constraint that you're going to fill in right there will make another shaded region. Another shaded region. For now, we have this shaded region, but you have one more to come up with, and then I'm going to let you take it from there. You got the corner points. You can put those in place. You want to evaluate those corner points, evaluate them, and come up with your answer. Let me help you get started with one of these systems. If you notice, the directions are to do 3 out of 4 of these. And I actually suggest that you start with number 3. Okay, it's just kind of a nice problem to start with. I'm going to help you get started. We've got this thing called the substitution method. Substitution method works nicely if you can solve one of the equations for a variable. Like maybe the first equation, Equation A, we solve it for y, right? I mean, it's already almost solved for y. All I got to do is subtract 2x, gives you negative 2x. Subtract 5z, gives you negative 5z. And whoops, I still have my 20 out there. Now, remember how this works? You have to take this y equals and you have to substitute it in, not once, but twice. I have to substitute it in very carefully to equation B, and I'm also going to have to substitute in equation C. I'm going to show the equation B substitution right now. Ready? Here we go. We're going to substitute in to that space. We're going to substitute in this equation. So I got to squeeze that in there, negative 2x, negative 5z, and 20. After I squeeze that in there, I have to distribute this 2. So that means everything's going to get doubled with the negatives. Make sure you double 20 to be 40. Okay, now we're on the right track because we're getting 2 variables. We're going to combine these x's to be negative 8x. We're going to combine these z's to be negative 17z. That's 2 variables. That's good. By the way, I got to subtract 40 over here. That'll get you negative 37. But I need another equation. How do I get that other equation? That's right. You're going to substitute in again, but you got to substitute in to the equation we haven't used yet. Once you do that, you want to take what you get and put it with what we just found, and then you gotta do the substitution method again with your smaller, simpler system. All right, so you can finish this problem if you want. You can go back and finish the linear programming problem. Little practice. I will be collecting it. There'll be a small grade, but ultimately we're trying to give you a chance to get these things figured out before we take the mid-chapter test.